2 minutes, sir. He will come directly.
Please take your time.
2 minutes.
Never mind. Thank you, ma'am.
So, Namaskar, am I audible?
Very much, Professor. I can hear you very clearly. It is nice hearing you. Please.
Thank you, thank you. First of all, a very good morning from Microbiology and Amity University, Rajasthan. And this is a part of industry integration. So Professor Geeta Madam is coordinating, and my friend Sanketji, who is heading microbiology as a deputy director. So Professor Natarajan, welcome to university for this interaction on a very important topic, bioremediation. So, Professor, you are from Sohar University, which is a industrial platform, and and you have selected a bioremediation. So, I think a very high level integration of the industry, and you are in the remediation side, which shows that biological treatments are more important. Am I right?
Very true, Professor.
Yeah, so thank you very much for giving consent. And here also few scholars are working in cadmium, in mercury, and in one more compound, I forget. But cadmium and mercury are the major one in the Kanpur area.
Very true. Very
In,
true.
in
You will see
Italy.
lot of examples today. I myself fine tuned to suit your scope and your future plans, and you will find lot of interesting and common things, and you
Yes.
will see it during the presentation. Of course, Professor.
Great. Happy to see you, and very important topic. Students, bioremediation is one of the very important area where industries are growing, and India is a developing country, fastly developing country. So we cannot switch off the industry. Whatever is coming out from the industry, we need to treat. And if we treat with some biological regime, then it will be a long-lasting, sustainable solution for all problem what we are creating, because we are running industry for our needs. And as we are creating industry, so we are equally responsible to treat. So, right, sir, from microbiology department, this event is by Professor Geeta, Sanketji is here, and my friend Professor Gaurav and Professor Dipti. और कोई faculty है? Yeah. So Professor Gaurav, Dipti, myself, Sanketji, Professor Geeta, and my PG and UG students of microbiology. So I think we people are teaching in classroom, but we are not comparing ourselves with industry. And you are dean, and you are researcher, and you are in the industrial town Sohar port. So welcome. You continue, discuss with the students, and the students enjoy this interaction, as sir has given the important R to you. So we are big thankful to the expert, big thankful to Professor Geeta Madam and the entire facility creation. So listen carefully, ask some question, and understand, because this is the topic of today, and this is the topic for future also. Because industry होगी, pollution होगा, pollution को ठीक भी करना होगा, और industry के साथ we need to continue the growth. So if you want to continue the growth, then you need to take care the pollutants. So best wishes. Thank you, sir. Please continue. Geeta madam is coming. I am sitting in front of you for some time, and then we will continue. So thanks for creating new friendship. Thank you very much.
Appreciate, Professor. Thank you very much. It's my pleasure.
Thank you.
Welcome all of you. It's my pleasure to introduce Dr. Raja Mohan Natarajan, PhD in Chemical Engineering. He is the professor and assistant dean at Faculty of Engineering, Sohar University, Sultanate of Oman. He has more than 26 years of experience. He has a lot of collaborations and consultations with the industries, which includes Sohar Industrial Port, OQ, Oman, Majlis Industries LLC, BIA Oman, Sheffield, UK. He has lots of publications in reputed journals, and he has citations of around 5,004, H index of 42, and I-10 index of 113. He has been awarded as the top 2% scientist in Stanford list in 2023 and 2024. He has also awarded as an outstanding young chemical engineer in Indian Institute of Chemical Engineers. He has lots of professional activities, and he's a member of a lot of professional bodies. I welcome you, sir, and thank you very much for accepting our invitation. Over to you, sir.
I sincerely thank the warm welcome and detailed introduction given by the Honorable Director of Amity Institute of Microbial Technology, Professor Sri. And I sincerely thank the very brief introduction and a very up-to-date resume of mine given by Professor Geeta. And she spoke very high about me, and it is just a part of my long time journey, both as an academic and a researcher and an industrial collaborator. I take this opportunity to thank Prof. Sanket, who is my close friend since his association with Sultan Qaboos University in Oman. And I thank all my colleagues, the professors and the academic staff, undergraduate students and postgraduate students with Amity University, Jaipur, for attending today's presentation. So let me go into the topic. As very well emphasized by the Honorable Director, bioremediation is a need of the hour. And I would like to emphasize that bioremediation is not very new. It has been with us for quite some time, but it has gained importance due to the ever-growing pollution and the industrial expansion happening globally. Let me give you a good overview. And as I was informed by Prof. Sankat, it's going to be a heterogeneous group where I have both undergraduate students representing microbiology and biological sciences and postgraduate students. You will have some introduction, some basic principles, and of course, I will show you the current status of where bioremediation stays and how you can take it forward for future research. And I am a chemical engineer who is specialized in environmental biotechnology. I make sure I speak more relevant details related to biological sciences, especially microbiology and biochemistry. And I restrict myself talking from the engineering point of view, where I emphasize more on modeling and optimization. So I will try to strike a balance. Incidentally, all my talk will be more focused towards metals, toxicology, and application of bioremediation. And it is a coincidence that the Honorable Director very much emphasized that Amity is currently focusing on heavy metal depollution, namely cadmium, mercury, and you will find a lot of useful things. And this is just an icebreaker, which I wanted to provide as an opportunity. And I would like to serve the student diaspora, either it is in India or rest of the world. And I am always available for any support. Being a teacher and an experienced researcher, my first purpose is to help people by sharing my knowledge and experience. Of course, you have a great team in Amity, and I'm adding to whatever they are offering. To start with a simple question to all of you, maybe many of you know it. Of course, I would like to emphasize, what is bioremediation? Is it something new, or is it a recently emerged area? What exactly we mean by bioremediation? What does bioremediation do or involve? The simple definition, as you go by any standard text resource or a research resource, any process where you have microbial reactions that degrade or transform. I use both the words, degrade or transform. Contaminants, rightly said by the director, pollutants. Pollutants and contaminants they are synonymous. You can use them in any place wherever applicable. So this is the basic definition of bioremediation. Then coming to a very tricky question, is bioremediation same as biodegradation? Can I use vice versa? The basic difference is biodegradation is defined as something happening naturally. Naturally happening changes is what mostly they mean by biodegradation. But sometimes they are used synonymous. bioremediation is addressed as biodegradation. Biodegradation is interpreted as bioremediation. All biodegradation can be counted under bioremediation, but all bioremediation need not be biodegradation. That is a very thin gray line. To be more specific, bioremediation is an engineered process. I use the word engineered means modified. Engineered means made to purpose. Engineered means tailor to fit what we need. This is a clear comparison between how we differentiate bioremediation and biodegradation. Let's go into the details. Let me expose you into the depth. And very coincidentally, all my discussion, I'll be focusing, rather than talking general bioremediation, I'll be talking to you about how do bioremediation fit into heavy metal depollution or heavy metal application. So I'll be exposing you good amount of information on toxicology of heavy metals, subsequently bioremediation as a potential tool to treat heavy metal pollution. So bioremediation, as you are aware of, it is a process of utilizing diverse microorganisms to eradicate pollution from every possible place in our environment. Rightly said by the director, all industries, irrespective of the nature of the process or application, they do involve metals in different places, either as in the raw material side or during the process side, or it is a catalyst. So metal involvement is present in different places in different types of industries. And wherever we have metals involved, entry of metals through effluents, either through water, air, or soil, is a huge challenge. And how are we going to address it? Bioremediation is a potential alternative. And in bioremediation, do we have one plan or do we have multiple options? The broad classification is in situ and ex situ. In situ is like at the point, wherever the pollution is. In situ refers to its strategy without excavation. We can treat it together in place, in the site. And bioremediation is predominantly for soils. When it comes to water, mostly we call it water treatment. Bioremediation is specifically used for solid waste pollution treatment. And what is ex situ? Ex situ is you relocate the polluted soil, or you relocated the polluted environment, a part of polluted environment, and I try to treat. There are different ways. Percolation, bioventing, biosparging, pump and treat, bioslurping, all of them in situ. Ex situ, landforming. Composting, you relocate, you can treat, you use it for different purposes. Engineered biopiles, engineered composting, engineered landfilling, all of them comes under ex situ. Going to the mechanism, bioremediation is possible by different microorganisms, as you are aware of your basic microbiology course. But which species or which category of microorganisms are more helpful? Bacteria. They are very diverse. They are omnipotent. They are very versatile. So our discussion will be more towards bacteria. Whenever you see the presentation, you will find how wide scope you have. So bacterial bioremediation, principally we have three major mechanisms. The first one, transportation by efflux. Efflux is moving out. Enzymatic conversion to less hazardous form. It is conversion, more like the microorganism and the enzyme involved with it. And third one is sequestration. Sequestration involves heavy metal importing. Then subsequently, you have different mechanism through phytokeratin, metallothionein, metalloregulatory protein. This is intracellular sequestration, and something outside the cell is extracellular sequestration. Most of you might have learned much about intracellular mechanism and extracellular mechanism in your microbiology course. And whatever you learn in microbiology is very much applicable for bacterial bioremediation, where things can happen inside the cell. Also, the things can happen outside the cell. Outside the cell is predominantly through extracellular enzymes. Let's go into the generally favorable features because of which bacteria remains microbiologists' all-time favorite. Bacteria remains the best friend for environmental biotechnologists. Bacteria remains a potential solution for all environmental microbiologists who look for creating a safe and greener environment, as rightly said by the Honorable Director, a sustainable solution to pollution. You attack pollution through natural resources. The first and foremost point, what I see here, ubiquitous. Ubiquitous is versatile. All bacteria are ubiquitous in nature. They have active binding sites, surface property. The cell wall composition of bacteria is very favorable to absorb and react. Ionic charges of cell wall, it's a surface property, which will make the bacterial biosorbents very effective. Genetic composition makes it more suitable whenever we talk about intracellular mechanisms. And availability of sugar on cell membrane, it's always a very favorable property when you talk about bacterial growth. And bacterial biomass have the tendency to bioaccumulate easily. And all bacterial surface have high surface to volume ratio, higher surface area, always favorable for passive uptake, which I mean bioabsorption. Going further, this adds to what the director and currently the institute is focusing through master's research, PhD research, and I have observed a lot of activities through your social media. Even Prof. Sankat used to share me a lot of activities being happening at Amity. It's very nice to notice. And you have been focusing on cadmium and mercury, two high priority pollutants. Now I'm going to talk to you about generally how heavy metals are very, very toxic and carcinogenic. And the first example, as you see in this, that the first and foremost, cadmium is present. Of course, mercury is there too. Cadmium, lead, this presents a broad range of metals which you find in different resources, different released wastewaters and solid waste. So where do we find heavy metals? Heavy metals are very much used in plastics. Heavy metals are very much used in fertilizers. Heavy metals are present in sewage sludge. Heavy metals are part of solid waste. Heavy metals are part of energy industries, like a petrochemical processing plant uses a catalyst. I've been working with refineries for more than 2 decades. All refineries cannot function without a metal-based catalyst. So metals do enter their wastewater, metals do enter the solid waste, metals do enter the air release. So metals do enter the ecosystem by different modes. And wastewater treatment plant, one of the serious challenges which currently all GCC countries facing, selenium pollution in wastewater. A very difficult challenge. Membranes are expensive to handle. Microorganisms are super specific for selenium, but we need to genetically modify them to improve their efficiency of recovery. Selenium is the latest in the list. What are the classical ones? Like the director, Professor Asri said, cadmium, mercury, arsenic, nickel. They are classical pollutants. They will be with us for a long time. The new addition is selenium. I have been working on certain projects to address the selenium pollution. I'm working with the refinery. Also, I'm working with the Majis Industries who handle the wastewater treatment plant of refinery. And due to the NDA non-disclosure agreement, I can't disclose much because the research is still under development. So these are the scope where you can find heavy metals, and it is through solid, gas, and liquid. And what are the impacts of heavy metal? They have a broad range of human impact. Heavy metals, potentially carcinogenic. They can create cancer. Heavy metals are potentially carcinogenic. Heavy metals lead to renal failure. Kidneys cannot separate or digest metals. It's a load on the kidney, skin, nervous system. High metal, it can lead to neuromuscular disease, heart disease, respiratory illness. So heavy metals have a very significant impact on human health. And where do we talk about these heavy metal sources? Naturally, abrasion of rock. All rocks are metals. Anytime when you have a mining industry do have metals in day-to-day operation. Volcanic eruption. All volcanoes release metals. Forest fire. We have seen how California have suffered, and it is irresistible. You can't control. And wind, dust carry them. These are the natural resources. Coming to anthropogenic, anthropogenic refers to man-made. Domestically, we use metals everywhere in our home. Solids, waste, materials, construction materials. So industrial source, atmospheric release, metals, cement industry, refinery industry, Steel industry, you will find metal dust in the air. Coming to water, a refinery will have metals. A steel plant will have metal. We have the biggest steel plant of Oman here, Jindal Shadid. Of course, it belongs to the Jindal Steel of India. We have the biggest plant. Two of the main steel plants of Oman are based from Indian manufacturing sector. And we have fertilizer industries. We have pesticide industries. A fertilizer industry use metal as catalyst. We have Sohar International Urea here. We have a urea plant. We have ammonia plant. All of them have fossil fuel burning, of course. All our automobiles contain lead. Lead is being added as a promoter of fuel properties. Lead waste, biomedical waste, a huge challenge. Post pandemic, a lot of research on how to handle biomedical waste. All biomedical waste are potential metal contaminants. So what is the pathway? How do they enter? When I talk about the sources, they enter through three channels, very unique. When we talk about gaseous pollutants like benzene doesn't enter much through soil. Benzene's entry is through air majority and little through aqueous media like water. But what is unique with metals, it enters equally bad. I avoid the word equally good. Equally bad in air, equally bad in water, equally bad in soil. And bioremediation have significant application in all these three. I am a rare mix. I am specialized in biofiltration, which I can present as a different lecture. Biofiltration is a very unique proposition. I talk about only air pollution control through biological treatment. Like Professor Asri said, I'm specialized in biological pollution control for air quality, which is a different portfolio. I am specialized in water treatment, and I have been working for biodegradation, and I have been working on bioabsorption for a long time. As rightly said by Prof. Geeta, my Google profile will show you I am too many. I have been working on multiple directions, and soil is my recent addition. I have been working on industrial consultancy on bioremediation of soil. I have not published much because I am working towards something on patenting and IP, and I'm working on soil bioremediation too. And how do it enter? Plant source, very potential. All soil bioremediation, air and water, they ultimately land on plant. Root uptake. Then subsequently, this will enter the ecosystem, birds, domestic animals, fish. Then subsequently, we consume them as humans. Japan have a long-standing history. Mercury pollution in Japan, it enters the food cycle through sea, seafood. Minamata disease, you can read historically. Whichever country who have huge consumption of marine resources as part of their food chain, you will find a lot of metal impact on human health. It is very interesting. You can read a lot and you can channelize where you want to work. Marine, very interesting. Birds, of course, all of them through plant source. This is what the director has been explaining you. All these shows the potential effluent releases reported in the media. I don't want to mention which part of the world. It is everywhere. It's everywhere. Some of them are treated. Please bear with me. They are discharge points into the rivers. It's not an entry point into a water treatment plant. Please be clear. These are the discharge points. These are claimed to be treated waters. Still, if you go and test, you may find traces of metals which will enter the lakes, which will enter the holy rivers of the country, which will ultimately end up in bioaccumulation, heavy metal accumulation in the ecosystem. How are we going to address? You, the microbiologist, have a significant role to play as an environmental engineer. I call you as an engineer. I don't differentiate science and engineering much because both science and engineering are intertwined, interdisciplinary. And a lot of Western countries believe interdisciplinary research needs engineers and science specialists equally. I had a different opinion in early stages of my career. After seeing Prof. Sankat's contribution in Sultan Qaboos University, I fully acknowledge he might have contributed more than me to the field of environmental pollution. He's a scientist who worked with engineers. He worked with the Petroleum Institute, which is a strong fort of chemical engineers like me. But a microbiologist like him has contributed very significantly. And every one of you have a very significant role to play in interdisciplinary research. And this is what we are going to see, how we are going to prepare a conceptual approach to address this. Coming to the point now. So where do we focus? Industries, transportation, residential use, mining, agriculture. All these places will provide you effective raw material to treat either through air, gas, solid, liquid discharge, solid waste. Directly, they can enter the atmosphere, they can enter the river, they can land up in the landfill through different sources. And where do they affect? They affect the soil health, they alter the microbial diversity, ultimately they affect the crop productivity. How are we going to focus? Bioaccumulation, biodegradation. This is where we have two alternatives to work with. Bioaccumulation is morely passive, relocation of problem from one place to another. Works well with inorganic. Biodegradation very well works. It's active. Conversion of organic. So what you are working, you choose either path A or path B. It depends on your raw material nature. You can't do everything with every raw material. The pollution source, the pollutant nature decides which process is suitable. Fine. Let me show to some toxicity aspect. This is the first toxicology. As rightly said by our honorable director, you find mercury here, you find cadmium, where Amity is currently doing great job through PhD research. All these heavy metals, they will reduce mineral uptake, they will reduce photosynthesis, they will reduce respiration, they will reduce seed germination, they will reduce plant biomass. Ultimately, all your agricultural parameters are significantly affected. Indirect effect. Then I come to plant physiology or plant anatomy, lipids and DNA, chromosomal aberration, cell injury, chlorosis, enzyme activity, damage to cell membrane. This is more towards plant biotechnology. This is more towards agricultural productivity. On the whole, I talk a lot of biochemistry and biotechnology in this slide. Coming to the toxicology, as I explained to you before, significant effect on heart, blood, vascular system, brain, lungs, and of course, a lot on reproductive system. Heavy metal is a big headache. Heavy metal needs high priority. Heavy metal needs immediate attention. What are we going to do? Now, this is like anyone, if you are preparing for research, either at the bachelor level, master's level, or a PhD level, the next 5 to 6 slides is your literature review. You are going to hear from me what you normally understand by reading for hours, weeks, or what you browsing Google Scholar for 10 hours, reading 25 articles. This is a detailed review of where do heavy metal sits, what are the priorities. Cadmium, very rightly said. I did not make this presentation to suit Honorable Director's presentation. This is the order. Cadmium pollution, a serious challenge, followed by lead, copper, zinc. Where do you find them? They are all metallic. They are not molecules. They are all ionic. What do they create? Damage to soil, plant, human health. This is the first step. Why do you choose your topic? Toxicology. Focus on toxicology. Very important. Toxicology is the preliminary phase before identifying a potential topic. And all this toxicology is applicable to all over the world. And India, with a diverse economy, diverse industrial sector, diverse commercial activities, you will fit yourself in each of the domain. But my application is for all over the world. I speak about the global perspective. Where do you fit yourself as a microbiologist? Again, you have, being a microbiologist, you always have a alternatives. Bacteria can help, algae can help, fungi can help. My PhD thesis is on fungi. I work on Fanericare Chrysosporium way back before 24 years. I started my life as a doctoral researcher with microbiology aspect. I worked a lot, early stages, fungi. Then subsequently, my exploration is more towards bacteria and algae. And I'm specialized in marine algae. Marine algae is very well a sustainable solution for this part of the world because Oman have a very long sea coast and the Arabian Sea have very potential unique algae. I've been working on a lot of marine algae species and all of them present you potential alternatives. And I don't want to teach you about each of the species. Pseudomonas, Bacillus, D-sulfovibrio, E. coli. You might have heard of them in multiple places in your courses. Where do they help you? Cadmium, rightly said by the director. Mercury. And what are the possible mechanisms? This is what you will study in your research. You will rule out or you will complement. There are both possible. Sometimes it can be complementary. Both bioabsorption and bioimmobilization can happen together. Or you will say, in my case, it's more bioabsorption, not bioimmobilization. Extracellular sequestration, very unique. Bioprecipitation, a different mechanism. Intracellular sequestration, all these is what you will explore during your master's, bachelor, and PhD research. Very potential. Algae, predominantly bioabsorption. Bacteria, very versatile. Professor Sankat have huge experience. And all your professors in Amity, they might have explored a lot. You'll be hearing a lot from them through your lectures, and I add to what they have introduced you through courses. A detailed presentation, and this is part of published literature where I have been helping some researchers, and Anjali is one of the very promising researchers who have been working on thermophilic organism. I've been working and I've been helping them, and her studies is more towards removing heavy metal from her study area, predominantly near Himachal Pradesh and some other locations of India. And she has worked extensively on thermophilic bacteria. Thermophilic bacteria work wonders at high temperature. And my interest towards thermophilic bacteria is justified because the average temperature in Oman, we have 4 months of summer. Our average temperature is close to 35 to 40 degrees. We reach 40 degrees very common. And our summer is very long. We have longer summer, very long summer, 5 months of very high temperature. So we can talk about different bacterial species. Metal resistant genes, I talk about genetic manipulation. I talk about heavy metal resistant gene. These are reported literature, started in 2008 and it is reported till 2023. Look at the evolution of the research. Chromium. Chromium is being considered as a priority for the past 15 years. It's because it is being continuously zinc, a lot on zinc, copper, cobalt, cadmium, nickel, mercury, very interesting. Mercury is a classical pollutant, arsenic. So all this has been done. What you are going to add, that is what I would like to say. We have to be unique. We don't need to repeat. How I am going to genetically modify, how I am going to work on recombinant. All these are, it represents a lot of modified. That's why I say engineered. Engineering microorganism, that's your field. How do you modify the microorganism? What genetic manipulation you can do? You have a lot to offer. Please review. I'm ready to offer any support. Of course, the professors in Amity are very well placed. They have huge experience to guide you. Please be aware. There is a lot of potential. Coming to specifics, what mechanism? How do mercury is reduced? And which microorganism is effective in doing it? Bacillus, Klebsiella, Pseudomonas. It has been reported. Can you genetically modify them? Can you bring new scope, new scientific idea to this? Can we reduce this bioreduction? We call it heavy metal reduction. Reduction of ion 3+ to 2+, hexavalent to trivalent, 5+ to 3+, uranium. Manganese, selenium. This is where I am currently working on. A potential challenge faced by petroleum refineries in this part of the world. Vanadium, molybdenum, silver, tellurium, a broad range of metals and a huge choice, diverse choice of microorganisms. This is what you will find from a literature review. I don't want to deep dive. Deep diving is one-to-one interaction. I can talk about one research study. Since I have a diverse audience, I have bachelor and master's and PhD students. Bachelor students, this is quite interesting. For masters, any of them working on heavy metal, bioremediation, this presentation is part of your literature review. This is an eye-opener to know what has been done earlier, where successful results, 100% efficiency, Pseudomonas. So how I am going to improve where I have less? So it's a cost and efficiency trade-off. I need to also justify the economics. What condition do they require? Are they expensive to grow? Are they expensive in terms of conditions? So we need to be aware of all these things. You have a broad range: Gemella, Micrococcus, Bacillus, Pseudomonas, Sporosarsina, Acinetobacter, very Staphylococcus, a broad range of microorganisms, especially bacteria. My focus will be more on bacteria. Look at the concentrations, 20 milligram, fairly good. Big, 100 milligram per liter, very high. Still you can have, this will give you a complete range of what has been explored. And this is part of published literature, which I have been associated with. A detailed review of bacterial bioremediation of heavy metals. I have chosen a topic which adds more value, as rightly pointed out by the Honorable Director. Amity is currently focusing on heavy metal bioremediation. Very, very useful for you. And you can do a lot of wonderful things. And coming to the mechanism, now comes some deep diving. Main sources, where do actions happen? Anthroposphere, lithosphere. Metal solution, water, soil. Bacterial bioremediation, metal polluted water, soil, treated with bacterial biomass in vitro. What is happening in vitro? Three mechanisms: bioaccumulation, physical; biosorption, physical; bioremediation, intracellular. It is microbiological, chemical. I use the word physical, chemical. Chemical can be always related as microbiochemical. I use a new word. You like to have microbiological? I complemented it by chemical. So I use the word microbiochemical. Microchemical. So intracellular. Enzymatic action. Extracellular enzymatic action. As you know, enzymes are present inside the cell wall. Intracellular enzymes. Enzymes are released by the microorganism extracellular. Both can happen. Extracellular is what I call the efflux. Intracellular, sometimes it is called the influx. After bacterial remediation, the toxic metals are converted to non-toxic. This is what we call bioreduction. Reduction in the concentration. Reduction in the toxicity. A toxic pollutant converted to non-toxic. This is the deeper studies which you do in your labs during bachelor, master, and PhD thesis. This is the deeper study, what you will do. Where does it fit? How results are reported? Hot spring water, very unique. This is the research I am associated with as a mentor. We have demonstrated to isolating strains, supercapacity strains from hot spring water. Why do we prefer hot spring water? They are thermophilic. They are from natural environment. How do we isolate? We purify, we modify, we do detailed RNA profiling. What are the three species which we have achieved excellent result? Bacillus cereus, Ocinobacillus, Bacillus composti. Manganese is the target. 98% strain TA2. 98% is excellent. Even no other chemical method can do, because metals are chemically resistant. So microbiological approach, very effective for heavy metals. Heavy metals are highly resistant to chemical changes. You can't change them. Laboratory scope. What analysis? I should congratulate Amity for expanding on analytical facilities. I've been following the social media post. Of course, Prof. Sankat used to update me occasionally. You have got excellent facilities and you are expanding very nice with the addition of advanced facilities like scanning electron microscopy. You have gel page. You have all gel electrophoresis, all you have in your facilities. So you can work on heavy metal side, like using atomic absorption spectroscopy or ICP. You can work on microbial characterization. We can do a lot of molecular identification. All these possible with the excellent facilities around you. So what bioremediation can do? A polluted environment can be converted into a very sustainable and eco-friendly environment, which we call a safe environment. If you name SDGs, bioremediation can attend, or it can address at least 6 SDGs directly. And I will say all the 17 SDGs will be addressed directly and indirectly. Safe health, economy, create jobs. When economy, when industrial sector survives due to environmental sustainability, you create jobs. Quality education. What is the relationship between quality education and bioremediation? Bioremediation enhances the quality of education because you are doing something meaningful to the society. That's what I always say. Impact of studying. What is the impact of your degree? The first impact, you should improve community, the quality of life. Next impact is about yourself. Next impact is about science and technology. The first impact, how you help the environment. How do you help the community to make the life better? I make community means all. I talk about plants. I talk about animals. I talk about aquatics. Everything comes into place. So these are the main references which I have used. So I believe I stick to the time. My presentation was close to, as I promised to Prof. Sankat, I said I will finish it in 40 minutes. Exactly, I spoke for 40 minutes. Still, we have 8 minutes time. I am available if you have any queries on this topic or any other related topic. And I have given you my university website address. My Scopus ID is available. My Google Scholar profile is available, and Prof. Geeta is very kind. She updated you my latest Google profile, Google Scholar profile, because I didn't update Prof. Sanket anything in the last 2 weeks. And what she said about me is applicable as on today, because a couple of days back only I cracked the 5,000 citations. The target. Maybe it's fine. I don't count Google Scholar or Scopus as the only measure there, but they are good measures. There are many other measures. Many of your teachers, they carry 20 years of experience in the field of microbiology, in the field of biochemistry, in the field of biochemical engineering. Their experience is equally good, or sometimes more than what you see in Scopus profiles or Google Scholar citations. So I wish all the Amity team, the students, professors, and the management a very great success. Amity has been doing so well. I've been observing you, a lot of activities. How do you do extension activities, collaboration with the international partners, collaboration with industries, lot of outreach activities. I see the posts by Amity microbiology team on the workshops conducted on advanced analytical equipment. They do a lot of activities, and I'll be very happy to collaborate on, and I'm learning a lot of things from you also. And I am a continuous learner. And Prof. Sankat has been a good motivation, and he's a good role model for you all, and sometimes for me also. Thank you very much. And I leave the floor to discussion. If I can clarify you, I'm very happy. I'm available for the next 10 minutes, please.
Thank you. Thank you very much, Prof. If you have a question or two, please go ahead. You can come and ask us. So thank you very much for giving a very nice overview to all of our students. So we have a question from one of the students. Gaurav, he is
Please.
a master's student So he would like to ask you something. Please go ahead.
Please, please.
Good morning, sir. This is Gaurav from MSc Industrial Microbiology. So a warm welcome to MIT. So, sir, I had a initial experience of doing bioremediation. Through biosurfactant under the mentorship of Dr. Sangeet sir. So
Please.
that went well, and we are on it only. But I had a just basic question, like how do we identify the gap? Like I want to do bioremediation on a particular thing, but I don't know how to find the gap in particular region maybe, or what do you
Yeah,
say?
it's an interesting question, Gaurav. So what you ask is more about a research perspective. I fully understand. Biosurfactant is a recently emerging field, and it's very, very useful whenever you talk about oil or organic pollutants. And Prof. Sangat has done exceedingly well when he was with the Petroleum Research Institute. And I appreciate you taking up a very nice activity. And what you talk is about research gaps. Research gaps can be learned through multiple ways. And the hard way is to by reading by ourselves extensively through Google Scholar, through open access journals, through scientific databases. There are so many ways. Only by extensive reading you can do gap analysis, number one. Number two, some senior resources of field specialist like Prof. Sankat. Prof. Sankat has been working on biosurfactant for, if I am right, for more than 10 years. He can have a good idea on that. And other than that, people like me, I can be of a useful resource. And people, any of your colleagues who is working with other institutions who are specialized in microbiology, either maybe from IITs, NITs, or private universities who are very strong in microbiology or IAC. And the second aspect, let me come to use of AI. There are so many AI tools, and I am having good experience with LitMaps. And I subscribe LitMaps. I have subscription. LitMap is a fantastic tool which will give you a good research gap and timeline analysis. It will give you what has been done in surfactant in which part of the world, and it will give you chronologically the literature, and you can zero from 100 to 20 in hardly in a day. How super smart you are in picking the keywords will decide how quickly you will go to the point. LitMaps is fantastic one, and Research Rabbit. There are so many other tools. My experience with LitMaps is good, convincing. These AI tools can save your time. They are going to complement research. They are not going to compete research. And I am a hardcore supporter of AI tools, especially as a complementing and a training source, not as a replacement resource. I don't encourage or I don't like to use ChatGPT or DeepSeek anytime to paraphrase or to write for ourselves. Thank you.
Got it, sir. Got it. Sir, I have this last question, like doing things on a lab scale and on an industrial scale are different. So how to scale your product? Like I have been doing it on a lab scale only, but I have not tried it on a pilot scale or an industrial or a field scale. So how to scale it? Like
it's very interesting, Gaurav. It's always even the biggest of the inventions. From the classical antibiotics, including penicillin, they all started from conical flasks. Conical flasks is the mother of invention, frankly speaking. Our life started with, I have to make it interesting, Petri dish, Petri plates, conical flasks are the first step to start even the advanced research. Scale up is very much possible. We have got fantastic biofermenters, bioreactors. We can even fabricate. We don't need to buy. We can fabricate a fermenter. We can assemble a fermenter. We can make a bioreactor. I have made a lot of bioreactors, both for degradation and for adsorption. If you talk about bioremediation, we can do. We can make a good reactor, and scale up can be done. There are a lot of resources available around. We can have batch scale, a 5 liter, 10 liter reactor, biosorber, then subsequently scaled up. Biofilters, where I have been working on volatile organic removal using microorganism, I have seen commercially successful biofilter which operate on meter cube capacity. I talk about 5,000 liters, 10,000 liter bioreactors. I have worked on them. Scaling up is easy, but at the lab level, you can work on a pilot scale. Anything around 5 to 10 liters, it can very well produce you good results. Thank you.
Awesome. Thank you so much, sir.
So our students were very happy when you said we should use AI and everything. So the first AI or the only AI comes to mind is, I don't know how many of you are using DeepSeek. I haven't used it. I didn't say. So they are much more advanced. So they are more into, so when you say AI, they think of ChatGPT and DeepSeek and other things which are available. So in the beginning, it was Wikipedia when we were doing our research. So for anything, people used to go to Wikipedia for inspiration. It's not good. It's good for time pass or something. So what you want to say is, it should complement your search. You should learn from it, not rephrasing or giving some ideas and everything. So thank you very much, sir. It was wonderful hosting you. Let's see in the future if we can host you physically also. So thank you very much, sir.
It is my pleasure, Professor Sanket. Thank you for the invitation, and I thank you, Professor Geeta and Professor Asri and the entire team, the professors of the Amity Microbiology Institute for sparing your time. And of course, you all have a great experience, and I'm just giving my viewpoint, or I'm sharing my experiences, and I always would like to compliment. And I learned a lot from reputed researchers like you and the students. I wish you all great luck. And you are in a very prestigious institution who house the best of the talent in the world in terms of your professors and facilities. So please make use of all these facilities. I wish you all a great success for a successful future. If I can be of any help, I am always available. My contact details are always with Prof. Sanket. And I am always ready to extend my help and extend my support always as a service to the Indian student community and the international student community. I have been in Oman for 16 years. Of course, I have my roots strongly rooted in India. Well, let us all hope for better collaboration of India with the world through resources like Prof. Sanket and myself and many other eminent professors who have been addressing you through guest lectures and workshops. Thank you very much. Wish you a good day, and look forward to meeting you either online or physical in some other occasion. Thank you.
Thank you very much. Looking forward for it, Prof. Thank you.